Everybody. So this is our last lesson of the year, and you have one assignment that attaches to it. Where do I have it here? Here it is. Oops. This is the lesson that supports the Polar Coordinates booklet, and we're looking at a new system of how to name and label points in a graph. So we'll talk about the polar coordinate system of angles. There's some small details I've got to talk about with that. And then we'll talk about how to convert from polar coordinates to XY coordinates and backwards and forwards. So this is your last assignment of the year. There is no test on this stuff. Please remember that if you need to do a rewrite or you missed a test, you need to make an appointment with me. Otherwise, your test you won't get credit for your test. You'll get a 0 on it unless you make your appointment if you missed it. So please make sure that you've taken all the appropriate measures. And I put this on our Edmodo account, so it's there too. It's in black and white if you need to see that. Okay, so polar coordinates. Let's talk about the polar coordinate system. Okay, so take a look at this graph of this particular point. What's the points? Well, what would you call the point as a value? You go 3 along the x and 4 up on the y, so this would be the point 3, 4, right? Yep, it's equal to the point 3, 4, 3 for the x, 4 for the y, but it's also equal to the point 5, 53 degrees. So this guy here is your xy coordinate point. That's one we're typically used to seeing, right? 3, 4, 3 for the x, 4 for the y. We call it our Cartesian plane point. Over here, this is our polar coordinate expression. So the same point, like the point doesn't change, how we name it changes. And the 5 stands for the radius, and the degree here stands for the degree, which we call theta. It's a Greek letter. I think it's like the 7th letter in the Greek alphabet or something like that. So what it is you change this system from being up, down, and sideways lines like you do on graph paper to circular graphs. And what you have is you have the distance from the origin to the point. That's the radius, like the radius of a circle goes around the circle. That's why they call it polar coordinate system, right? So I'm doing this in a mirror, so it's hard to do. So there's the radius. And then the angle, theta, represents the angle from the positive x-axis to the radius arm. Okay, so it's always from the positive x-axis. And when we count counterclockwise, we count positive, and we count clockwise, we count negative. So we're only really worried about the positive angle from here to the radius. So how do you figure that out? It takes trigonometry, folks. Make a little triangle out of it. Let me show you. Okay, so it's the point 3, 4. 3 for the x, 4 for the y. I can use Pythagoras' theorem to find r, right? It's just a squared plus b squared equals c squared. And the angle, well, I've got tangent, right? I've got opposite over adjacent, so I can use tangent. So I'll write out the t-chart for how to convert backwards and forwards first of all, to convert from xy to polar coordinates. Working backwards is a little bit harder, well, kind of a little bit harder and a little bit easier. I'll show you that after the first part. Okay, when we're talking about angles, first of all, we have to think about, okay, well, our angles start over here at the positive x-axis, and they go counterclockwise. So to the quarter pole, that's 90, like that perpendicular. All the way opposite is 180, 270, 360, and then we can keep going around infinitely if we like. But for now, we're just going to stick between 0 and 360. So let's get an easy example, and then we'll do a harder example. Alright, so let's say I ask you to convert the point to 12, 5. I know it's a little bit big, but it works out nice. So let's say I ask you to convert the point 12, 5 to polar coordinates, the r and the theta. So here's 12, 5, 12 along the x and 5 along the y. So there's your point, right? 12, 5. So I want to convert that 12, 5 to the same point, but written as a polar coordinate point. let's see how that works. Okay, so step one is you have to draw a triangle for the point, because we got to be able to calculate the radius and the angle, right? So let's do that. Okay, so when you're drawing your triangle, it's best to make it with the x-axis, the closest x-axis to the point. But you don't have to. You can make it with the y-axis if you like. You just have to be careful about how you do your trigonometry and how you sort out your angles, because it's not entirely clear all the time unless you have a particular method. So the method I'm going to show you is just the method about using the x-axis as one of your main sides to your triangle. Makes things a lot easier if you use the x-axis instead of the y-axis. But anyways, here's our triangle, right? I know I've got 12 for one of the sides and 5 for the other sides. I get that from my point, right? X, Y, so there's the x, there's the y. And I got to use Pythagoras theorem to figure out the r value. That's no big deal. I'll show the work. Okay, so, it's Pythagoras theorem, right? A squared plus b squared, so 12 squared plus 5 squared, well, 12 squared is 144, it's 25, 169. Remember, it's r squared, so I've got to take the square root, and I get 13. Well, that's the first part, right? 13. Okay, so now I've got to figure out the angle. Now, the angle I'm looking for is the angle from the positive x-axis, right? So this axis here, to the radius arm there. I want to figure out that angle. Well, that's just finding the angle of the triangle, right? It's no big deal on that. So let's have a look there. Okay, so right, I've got opposite and adjacent, so that's tangent, right? You guys shouldn't be a problem by now. So tangent of theta, there's theta. Go the opposite 5 over the adjacent 12, right? That's what I wrote down here. And if you go through that and solve it, you get close to 23. It's like 22.6 or something. But whatever, we'll round it to 23. So there's your point. 23 degrees. So the radius is 13, this guy here, and the theta is 23 degrees. And so we call that our polar point. The point doesn't, the point spot doesn't change. It stays where it is. I can either call it this way, or I can call it that way. And typically, up until now, we've only been dealing with this method. But that method is only good if you're dealing with things that are perpendicular to one another, like grids. But the polar coordinate system is very, very handy if you're dealing with circular momentum or circular cyclical events, or you want to model something that has like a cycle to it. You see it in real life. If you've ever watched curling, and who in Canada has never watched curling, the button, right, and that whole scoring system is a polar coordinate system. If you're from England, the dartboard is a polar coordinate system. We see them all over the place. We just don't really recognize them for what they are. Now, anything that has a circular motion, like a wheel or a gear, or the motions of the planets, or the motions of like electrons and stuff like that, it's often easier to model the math for them using polar coordinates. So it's another way to deal with things that move in circles, right? That's what makes them powerful. So there's the t-chart. I'll hold it up for you. Remember, clockwise is negative, so the angles count negative. Gosh, I can't do this. Angles count negative going clockwise, always from the positive x-axis here. This is 0. And counterclockwise is positive. So this way is how we measure positive angles. And I'm not going to get into positive and negative angles. That's a whole lesson unto itself. And since this is the last lesson we got this year, and there's a whole bunch more I'd love to do with you guys, we're just going to stick with some simple ideas for now. Okay, so I want to talk about being able to convert the other way. Or actually, what I want to do before that is I want to look at a question where it's not as cut and dry as this one. Now let's have a look at another example. Okay, so we call the, we're converting 3 negative 4 into r theta. And so, remember, here's the positive x-axis. We're going to have to find our radius to get down to the point. And the angle that we're going to get is going to be the angle that goes all the way around in the positive direction to where the radius lives. So here's the radius, and the angle that I want to find is that theta. Okay, so a couple things that we know, right? This is 0, this is 90, this is 180, this is 270, and then we go all the way around to 360 again, because 360 degrees in the circle. So the angle, the theta that we're going to have here is going to be between 270 and 360. We'll be able to figure it out exactly, but we know that this value here is going to be between those two numbers, between 270 and 360. Now, that's a little bit harder than you might think, because it requires an extra step in how you manage your calculations. So let's go through the process. Okay, so if you notice, I made my triangle with the positive x-axis as one of its legs. If it was over here, you'd make it with the negative x-axis. You always use your x-axis as one of the main legs of your triangle. And so I know that I got a 3 and a 4, so if I just take, their absolute values, this is 3 and that's positive 4, because we're only worried about the radius for now. And I say, okay, well, this is going to be 3 squared plus 4 squared, so 9 plus 16 is equal to 25, which is equal to r squared. Take the square root, so r is equal to 5. Well, so the radius, right, the radius from the center, sorry, I'm doing this in the mirror, it's hard. From the radius to the center is going to be 5 units long. So in terms of the clock, it's like, okay, well, here's the clock, and we're going to say it's 5 units, and then how far do I have to revolve it in order to get around to, to our radius arm. So now I need to be able to figure out this theta. But I can't just figure it out in one shot. I have to be able to do it in 2 shots. I have to be able to figure out this angle. That's fine, that's just tangent, right? Opposite over adjacent, so I got the tangent of, we'll call it x. Oh, sorry, it's bad x there. Tangent of x, we'll call this value x, is equal to the opposite, which is 4 over 3. And you can solve for that x, but that's not what we're going to put in there, right? We need the whole angle. We'll figure out part of it, but we need, the positive version of it, right? All that guy. That's no big deal. Let's do that calculation. Right, you do the inverse tangent of both sides, right? Turns out to be 53 degrees, but that's this angle here. This is 53 degrees. I want the other part of it. So to figure out the rest of it, my theta, well, I'm not quite at 360. I'm short 360 by this angle that I just calculated. So 360 minus 53, that's equal to what? 307. 307. And that's the angle that you put up there. So 307. So you got to be careful, right? Over here, if you're measuring on from the negative x-axis, then you're dealing with plus or minus out of 180, right? If up here, then you're subtracting it from 180. Down here, and you're adding it to 180, right? So you find these angles here, and you figure out whether you need to add or subtract to 180, depending on which quadrant of the xy coordinate system you're in. Okay, so that really is the way to convert from xy to polar coordinates. Now let's work at, let's go at working backwards. And it's actually easier to do, but the theory is a little bit harder to understand. So we'll spend a little bit of time on the theory, and then once you understand the theory, fly through it. It's easy algebra. Okay, so let's just quickly remember that we always start our angles at the positive x-axis, and we will go counterclockwise, right? We go in that direction. That's the positive way we measure angles. We can also go negative, but I don't want to do that in this lesson. You'll see it in Pre-Calc 12. So, okay, let's say I tell you that I've got the point 10, 217, right? And I ask, that's the r, and this is the theta. And I ask you to tell me its xy polar coordinate system. So, before we get into doing that, let's talk a little bit about what's happened, because, dearly beloved, you're gathered here today to witness the death of SOHCAHTOA. we use SOHCAHTOA actually to start us off with, you know, basic triangles and trigonometry. But after you get used to it, you know, SOHCAHTOA is a problem because you always got to watch what angle you're looking from, and that can lead to problems. Is it tangent? Is it cosine? Is it sine? You always got to be very thoughtful about what angle you look from in the triangle, and then which trig ratio to use. But in the polar coordinate system, we fix one of the vertexes of the triangle to the origin. And what that does is it fixes our theta. Our theta happens to be the angle from the positive x-axis going counterclockwise. And then our opposite and our adjacent, well, our opposite is equal to y and our adjacent is equal to x. And of course that's our radius. So sine, which we used to call opposite over hypotenuse, is now, well, opposite is y, and the hypotenuse is r. And that's always true for this system. And you can do the same for cosine. We can say that cosine theta is adjacent over hypotenuse, right? But adjacent is x, and hypotenuse is r, and tangent does the same thing as well. So I've got the tangent of theta is equal to opposite over adjacent, which is y over x. And that fixes sine, cosine, and tangent to the xy coordinate system, and we can merge both of them together. And it's this detail right here, and you should write it down for yourself so you can refer back to it, or at least scroll back to on the YouTube video. But you should write it down for yourself because this is going to be very, very important. Probably put it like on the first page of your assignment, or write it on a separate sheet of paper because you're going to need it. If you don't have it, it's going to be really tough. So let's keep this in mind as we go along. So if I wanted to find this, the xy coordinate system for it, well, I could think about what that means, right? So I've got a radius of 10 and 217. So 217 is between 180 and 270. My arm is going to be in here somewhere, and that's my theta of 217. Okay, so that's my angle, and I know that the radius is a radius, say, of 10. Okay, so you might think, oh gosh, I've got to draw triangles, and man, you don't have to. If you remember these things here, if you remember those things, life is really, really easy. And I'll show you. Check it out. Okay, so remember, our point, right, has an r and a theta, right? So the r is 10, the radius is 10, you can maybe envision it in your mind, and the theta is 217 degrees. So from these three equations, we have enough information to be able to solve for x and y. So step one is to set up two algebra equations. Well, what are you talking about? Okay, first of all, we know r and theta. So if I think about the first question, I know theta and I know r. The only variable that's missing is y. Okay, I know r and theta. So over here at cosine, I know r, I know that variable, and I know theta, I know this variable. So the only variable missing is x. So I'm going to set up two algebra equations, one that solves for y and one that solves for x. I say the sine of theta is equal to y over r, and I say the cosine of theta is x over r. Right? I'm using both of those. And right, I know r and I know theta, so I plug them in. Number 2, plug and chug. Right, I'm going to say the sine of 217 is equal to y over 10. Right, for the first one. And I just solve for y, right? No problem. I take the sine of 217 and then times both sides by 10. Right, times by 10, times by 10. So 10 times the sine of 217 is equal to y. I think it's like 6 or negative 6. Let's see what it is, right? 10 times sine of 217 gets you, oops, 10 times the sine of 217 gets you negative 6. So my y value is equal to negative 6. I do the same thing for cos, and that gets me my x value, right? I've got the cos of 217 is equal to x over 10. So times both sides by 10, right? So I get x, and I think that's equal to negative 8. 10 times the cos of 217 is equal to negative 8. Well, right, this is your y variable, and that's your x variable. So guess what? Hi there. So I have the point, right? My x value is negative 8, and my y value is negative 6. Job's done. Okay? You'd be like, oh, what about the tangent? Do I need to worry? No, don't need to worry about the tangent, because tangent, you're missing 2 of the 3 variables, right? So sine, I'm missing the y variable, I can solve by algebra. Cosine, I'm missing the x variable, I can solve that by algebra. And ladies and gentlemen, that is your last math duty of the course. Okay, so good luck, take care, stay tuned on Edmodo, and if you need to do any rewrites or anything like that, please make sure that you stay tuned and get in contact with me so that you don't miss out on your opportunities. Okay guys, take care, good luck.